Hello my dear friends. Today let us learn cyanides and isocyanides. Syllabus which we see, it is very limited and which can be completed easily. And there are only 4 points if you see in nutshell. Nomenclature and structure, preparation of cyanides from alkyl halides, amides and aldoxams, and preparation of isocyanides from alkyl halides and amines, and properties of cyanides and isocyanides like hydrolysis, Grignard reagent reaction and reduction and oxidation. Let us see the structure of cyanide first. Cyanide is nothing but it is a product of hydrogen cyanide. You could remember a hydrogen cyanide as HCN. If you replace this hydrogen with alkyl group, this is called as alkyl cyanide. And cyanide carbon it is having 4 bonds and nitrogen it is having 3 bonds and its valency is satisfied. So we can write R, C, triple bond, N. Instead of every time writing C triple bond N, we will write Cn as a combined and we can say RCN as cyanides. These cyanides are also called as nitriles and sometimes it is also called as carbonitriles because a carbon is attached to this nitrile group, we will call it as carbonitrile. And if you see the nomenclature part, generally this cyanide comes as suffix. This is a methyl group attached to cyanide, we are calling it as methyl cyanide. If it is attached to ethyl, we will call it as ethyl cyanide. And if it is attached to propyl, it is called as propyl cyanide. When it is attached to isopropyl, similarly, isopropyl cyanide. But when it comes to IUPAC nomenclature, we are using a tag or suffix as nitrile. You try to remember. And the beauty in this reaction is, here you can see 2 carbons. In this case, we call it as methyl cyanide because it is made into 2 parts. This part is called as methyl and this is cyanide, so we are calling it as methyl cyanide. But here in IUPAC nomenclature, there are 2 carbons. So 2 carbons it is called as ethane, and in ethane you are having a C triple bond which is called as nitrile, so we will call it as ethane nitrile. You remember that the carbon which is present with the cyanide functional group is also given number while you are numbering in IUPAC nomenclature. So in that case, this is having 3 carbons called as propane nitrile. Here you can see 4 carbons of butane nitrile or 2-methyl propane. This is IUPAC nomenclature. And sometimes it is also named with a common name, like we will call it as acetic acid with 2 carbons. So this is called as acetonitrile. So general method of preparation. In general method of preparation, we are going to prepare this compound from alkyl halide. We know alkyl halide is RX and we are going to add a sodium cyanide. In the sodium cyanide, this halide and sodium, they will come out as sodium halide salt, and this alkyl group will attach with cyanide in presence of ethyl alcohol water. When you gently heat it, you will get a cyanide. So try to remember that alkyl halide is having a halide. So we need cyanide and a salt which makes generally it is sodium. If it is a chlorine, it will come out as sodium chloride and you will get a alkyl halide. The problem with this reaction is aryl cyanides cannot be prepared. If it is a aliphatic like methyl, ethyl, propyl, we can prepare. When it comes to benzene, you cannot use this reaction because this cyanide group doesn't have a tendency to get into nucleophilic substitution. So that's why this reaction is not amicable for making aryl cyanides. And from dehydration of primary amides. Amides, you should know that C double bond O NH2. So this C double bond O NH2 group, it is having an oxygen on the carbon and 2 hydrogens on the nitrogen. So we are dehydrating. We are removing water using phosphorus pentoxide. When you heat this compound in presence of phosphorus pentoxide, the 2 hydrogens from nitrogen and 1 oxygen from carbon will be removed as water and you will get a alkyl cyanide. This is also one of the easiest method to prepare cyanides. And you remember dehydration. Water is removed, oxygen from carbon and 2 hydrogens from nitrogen, this compound is here. And there is one more method, similar method. Instead of using this amide, we can use a ammonium salt. Carboxylic acid, when it reacts with ammonia, you will get a salt. This salt can also be used to prepare this cyanides. Similar reaction, only the starting material is different here, and we are taking a ammonium salts of carboxylic acid. This will be removed water by using phosphorus pentoxide and on heating. You will get, initially you will get a amide. This amide, further it will give cyanides. So same dehydration reaction. dehydration of aldoxide. So you should know what is aldoxide. Aldoxide is nothing but a double bond, and nitrogen is having a hydroxyl group. This is amine with OH group, and you are having a C double bond O, which is called as aldoxide. So this aldoxide, you can see a H and OH are water can be easily replaced. This is acetic anhydride. That means it needs a water molecule. So it can take a water molecule from this molecule and you will get a cyanide. This is also the easiest method for preparation of cyanides. And next, most important, this is the 3 marks question. It will be asked in the examination from Grignard reagent. You should know what is Grignard reagent. RMgX is Grignard reagent. This is a magnesium salt. You are having a alkyl group, and this alkyl will have a minus charge. A carbene ion or C minus will be there, and you will have a X minus also. So magnesium is +2 and X minus 1, R minus 1 will be there. So this Grignard reagent will react with halocyanides. When halocyanides they are reacting, this alkyl group will come with magnesium and you will get a magnesium salt, and this alkyl group as a negative charge, it will come and sit on the cyanide, you will get cyanides. This is also a best method for preparation of cyanides, and this method it is asked in examination because it is a name reaction. How you will prepare cyanides using Grignard reagent. So simple, you take Grignard reagent and a halocyanide in presence of ether, the cyanide, the salt will be removed and you will get a cyanide compound. You try to remember the figure in this way. Next one is from aryl diazonium salt. This part already we have seen in diazonium chloride. We know diazonium chloride. 2 nitrogens with positive charge, you will call it as diazonium, and you are having a halide chloride. And this is a aryl group, a benzene-like ring is present here. So this will react with potassium cyanide, and potassium and this X they will go as potassium chloride, and this nitrogen it will be removed as nitrogen, and this aryl and cyanide they will react to give aryl cyanide, and this reaction already we have discussed, and it is called as Gutterman reaction. So in examination, Grignard reagent and Gutterman reaction they may appear because they are name reaction, and these are the methods for preparation of cyanides. Then physical properties. We should know that when the molecule is very small, generally it will be in the form of gas or liquid. So mostly these compounds they are in colorless liquid state, and when the number of carbons increases, they may convert into a crystalline solid. And when it comes to boiling point and ionic structure is related. When the compound is polar, it means it is having a positive negative charges, it will have a lot of attraction. When attraction is there, molecules will be together. When molecules are together, you need more energy to separate them. Slightly it is polar, that's why they are having a dipolar moment is there, because cyanide, the minus group is there, and alkyl there will be a tug of war, and it will have cyanide will have minus charge and alkyl group will have positive charge. That's why the melting points and boiling points are high. Then solubility. I already told you, when plus minus charges are there, there is a tendency of coming into water. So these compounds they are soluble. But the problem is the plus minus charges when are dominated by a alkyl group which is side by a alkyl group. With the increase of the alkyl group, the molecule will not come into water. Hydrogen bonding also will play an important role in this. Here with the water, it is having a weak attraction force which is called as hydrogen bonding. The attraction between hydrogen of one molecule and a highly electronegative molecule, other molecule, will have a weak attraction which is called as hydrogen bonding. So when cyanide group it is coming into water, it is having a hydrogen bonding. This hydrogen bonding is also responsible for the solubility. And remember that the solubility is very low. When the size of this alkyl group increases, the solubility goes on decreases, because this will dominate and it will take into organic delay. So all cyanides they will be easily getting dissolved into benzene or ether, like that they will be getting dissolved. Next, chemical properties. And first one is hydrolysis. Hydrolysis means simple, we are adding water. Water is HOH, and that can be in presence of acid or base. These compounds they will react. So here this C triple bond N they will react, and it will be reacting with water. That means OH groups will go to carbon and hydrogens will touch with the nitrogen. You try to remember as a layman. And what will happen? There is a bond formation. Here when the bond is forming, 2 double bonds they will make, and this carbon it will have 2 hydroxyl groups. When two hydroxyl groups are there, very unstable. You try to remember like this. And when they are unstable, they will give out water. When they give out water, it will form a C double bond O. So you can see here, when this nitrile or this cyanide, it is reacting with water in presence of acid. Initially, you are getting a amide. This amide further it will react with water to give this bond will break, and you are getting ammonium ion salt and you are getting carboxylic acid. So what you are supposed to remember is, here on hydrolysis, since we go to carbon and hydrogen to nitrogen. So nitrogen, hydrogen, it will form ammonia. 3 hydroxyls will come on the carbon and 2 hydroxyl group, they are unstable. That's why it is going as water. So you will get a carboxylic acid. You try to remember in this way, you can remember for long. The next one is reaction with alcohol. Same reaction, instead of water, water is HOH, we are using a alcohol R-OH. In this case, what happens? Initially, these 2 hydroxyl groups, they will go as water and you are getting a carbonyl group, but one of this nitrogen will go as ammonia, and this ROH group will come and attach with the carbon, and here you are getting a ester. So with alcohols, you are getting ester. When it is water, you are getting a carboxylic acid. When it is a alcohol, you are getting a ester. You try to remember. And you can see one more example. Here I am taking a cyanide. In presence of acid, it will react with methanol. So this methyl alcohol, here initially it will form a NC double bond, and next this bond breaks and automatically you are getting a C double bond O CH3. Reaction with Grignard reagent. Grignard reagent is RMGX. This RMGX will react in presence of ether. I told you R will be minus, MGX will be plus. So initially this MGX, as it is plus, this nitrogen pair of electron will react. So this nitrogen pair of electron will react with magnesium, and this alkyl will go to carbon. So you are getting a R prime will come on the carbon, and this MgX which is attaching to nitrogen, you are getting a intermediate. After that hydrolysis, here the bond breaking will take place. When bond breaking will take place, you are getting a C double bond O, which is ketone. So Grignard reagent, cyanide, it will give a ketone. You try to remember. Then reduction. Reduction is very simple reaction where you are going to add abundant number of hydrogens. When you are adding abundant number of hydrogens, what will happen? These double bonds will be getting saturated, they will convert it into single bonds. When you are adding hydrogens, this pi bond, it will have 2 hydrogens, this pi bond will have 2 hydrogens, so nitrogen will get 2 hydrogens and carbon will get 2 hydrogens. So overall this cyanide will be converted into primary amine in presence of reduction. We can use nickel platinum, or we can use a lithium aluminum hydride or sodium in ethanol. So these reactions will show that cyanide will be converted into primary amine. Then let us go into isocyanides. A very simple difference is cyanides and isocyanides are siblings. The only structural they are structural isomers. They are having same molecular formula, but the only difference is the functional group. In that case, it was RCN. It is in this case, it is RNC. We know that nitrogen can form 3 bonds and carbon 4 bonds. But if you see here, nitrogen is forming 3 bonds and it is having a pair of electron. These pair of electron will be donated to carbon. Nitrogen in its ground state, it will have 2 electrons, so it is forming 2 bonds. As it is having a vacant orbital, this paired dative bond formation or covalent coordination bond formation will take place, and you will get a alkyl isocyanide. Isocyanide, in the linkage cyanide, the alkyl group is attached to carbon. When it comes to isocyanide, the linkage between carbon, this alkyl group is to nitrogen, and you will have NC. So CN is cyanide, NC is isocyanide. You try to remember like this is isocyanide, and this is when the aryl group is there, we will call it as aryl isocyanide. And nomenclature very similar, only prefix we will use isocyanides. Instead of saying cyanides, we will say isocyanides. And these isocyanides are also called as carbyl amines. Cyanides are called as nitriles, whereas isocyanides, they are called as carbyl amines. And when it comes to nomenclature, same nomenclature, ethyl isocyanide. This is the ethyl group. You are having a NC, so we are calling it as a ethyl isocyanide in the suffix. Then general method of preparation. Cyanide, if you see the functional group, cyanide is CN. and these electrons, they will have a resonance. The electrons can be with carbon with minus charge, or these electrons can migrate to nitrogen. Nitrogen can have minus charge. So there is a possibility this carbon can attach, or this nitrogen can be attached in different cases. So just now we have seen what we told in the previous reaction. When alkyl halide reacts with potassium cyanide, in alcoholic potassium cyanide, we are getting a major project of hydrogen. But we should remember that a minor project of isocyanide is also formed. Why we are getting isocyanide? Here these carbon and nitrogen, they are having these there is a tendency dual nature. This carbon, when it is having a minus charge, it will get attached, and if nitrogen is having minus charge, this will get attached. So you are getting two compounds. And major product, generally I told you only we are getting isocyanide. No doubt there is a minor product, but you need not, you can ignore them. But instead of potassium cyanide, if you use silver cyanide, here the reaction will be reverted. This alkyl halide, when react with silver cyanide, you are getting a major product as isocyanide. So when they ask to write you about isocyanide preparation, what you are supposed to tell? Alkyl halide react with silver cyanide in alcoholic solution, you will get isocyanide. This is a comparison reaction. This is the major reaction. Primary amines. This is the test which we are going to confirm in the lab. Generally, primary amines, they will react with alcoholic potassium hydroxide and chloroform. This CHCl3 is called as chloroform, and alcoholic potassium hydroxide chlorine. And generally, we are going to heat it on the water bath. When you heat it, you will get a new compound, and you will get a isocyanide. How we will identify the isocyanide? Isocyanides, they are having a bad odor, with a bad smell. With the bad smell, it is a poisonous gas, and we can identify this poisonous gas. And you try to remember primary amines on addition of chloroform and alcoholic potassium hydroxide, and generally when you heat it, you will get a bad odor compound which is called as isocyanide, and these isocyanides are also called as carbylamine. So this reaction is called as carbylamine reaction. Isocyanides are carbylamine. And physical properties. Just now I told you the state, it is generally they are colorless liquids, and it is unpleasant in smell or bad smell will be there. When it comes to boiling points, they are less polar. The polarity is very less. So cyanides are more polar and isocyanides are less polar. That's why their melting points and boiling points are low compared to cyanides. Then solubility. When as they don't have positive negative charges, they will not like to come into water. Generally, they are soluble in organic solvents like benzene, carbon tetrafluoride. Chemical properties. Addition of water. So when you are adding water, what will happen? Already I told you, nitrogen will get hydrogens and C will get OH groups. So you try to remember in that way. In this case also you can see this nitrogen, it is forming a COH. That means initially you are getting a ene and alcohol. All ene you are getting. In next compound you are getting this part, it is called as formaldehyde. So this aldehyde form, it is a formaldehyde derivative we are getting. So generally what will happen? Isocyanides react with water to give, initially it will get enols, then it will be converted into formaldehyde derivative. And reduction. So when reduction, abundant number of hydrogens are added to isocyanides. So nitrogen and carbon, they will get hydrogens. So nitrogen and carbon, when they are getting hydrogens, the double bond, triple bond, they will be reduced. When they are reducing, you can see this nitrogen, it is having two groups on the two sides. So you are getting a secondary amine. So cyanides are giving primary amine. Isocyanides, they will give secondary amine. Then oxidation. Oxidation is simply, we are adding oxygen from outside. When you are adding oxygen, this can be with silver oxide, or we can take a ozone, or we can take dimethyl sulfoxide. All these compounds, this cyanide, they will react with the oxygen to give isocyanides. So you can remember a Bhopal gas tragedy happened in 1984. Union Carbide factory, they have manufactured this isocyanide, and that the gas was methyl isocyanate, which is called as MIC, methyl isocyanate. That gas was leaked from the industry, and thousands of people, they died and thousands were crippled. So you remember, this is more dangerous thing. So thank you very much for your patience listening. Hope you enjoyed. If you are having any doubts, you personally meet and try to get the information. Thank you.